Hi. Today's a special day because people are gonna quadruply change the world by a very tiny bit. Alright, so I got a whiteboard behind me to show what I mean. So, because they're redefining today the kilogram or they will also be redefining the unit for measurement of amount of particles, the mole. That's not a shortcut. They'll also be changing the unit for current, the ampere. Or amp, or that. And most surprisingly, they will also change the unit of temperature, or at least the scientific one, the kelvin. Well, all of these by very tiny amounts so that it doesn't really worry everyone, but the main one is this thing, the kilogram. All of these other ones depend on it. Now, to show why this is going to happen, we're going to have to tell a little bit of history. So, the first ever actually first the kilogram was called, which may seem really quite grave, but it's actually grave. It's actually grave, because it is a French word. But now, grave was defined as a mass of one meter of water at 4 degrees Celsius. All right. Um, and this was by Antoine Lavoisier. It was in the 17th century, or maybe in the 18th one, actually. In the 18th century, so this. All right, so what next? In 1889, it was replaced with a cylinder like this. It was declared kilogram of the archives. These are uppercase letters. Kilogram of the archives. But then, soon after that, it was replaced back because it was actually already used in 1791. And then, pretty soon again, in the 20th century, it was replaced with a platinum iridium alloy cylinder, which remains the definition of the kilogram until today, in fact. But it remains the definition of the kilogram. It's not really big, but it is 1 kilogram. It's the only thing in the universe that has exactly 1 kilogram, because it is the kilogram by definition. But now, sometime, but then it was discovered the mass of the platinum iridium alloy cylinder was actually divergent. But actually, there were, oh, I forgot to say this. There were 40 of them. inside that were given. And actually, this was all in Paris, by the way. This was all in Paris. The official definition of a kilogram. Now, in Paris, there are 7 of these. In Paris, there are 7 of these. They're called Big K. One of them is the official definition of the kilogram, sitting next to 6 sister cylinders, which they compared it to, and it's divergent. They're divergent. They have diverged a bit. And then the masses have further diverged. And to this day, the main one in Paris has gotten lighter. It was... Now, some physical process must have done that. But now, how to actually fix the kilogram? And that's what we're going to talk about today. Even though we already spent like half of this video, right? Just talking about the history of the kilogram. Alright, the next thing we're going to do is we're going to show 2 methods to change the kilogram and all of its dependence. Oh, I also want to tell how because along the way I said kilogram, but I started by saying grav because it sounded too similar to something else. But then but then after this, they thought that the kilogram was too big for the thing that they wanted to measure anyway, which means they turned to a gram, which was just 1,000 of a grav. But then that was too small, so they returned to the grav, but since they couldn't call it that, they instead started to call it the kilogram. 1,000th of a a 1,000th of a grav, 1,000 thousandths of a grav is a grav again, right? So we get a kilogram. Alright, so that's something I want to point out. History done. Let's get on to physics. And actually chemistry. So we'll start with the chemistry thing, which has actually already been done. Because I want to point out, this has already been done 4 years ago. But the votes said no, and so the kilogram has kept its definition. And so, since and so they thought that they could 1 kilogram sphere which only contain 1 isotope of silicon, and it's pure silicon. So it's only containing silicon 28. And then they have done something to make that silicon sphere, and then they accurately measured its diameter using a laser, and so then we get a sphere, which I'm just going to draw the circle, and diameter. Once you have a diameter, you can just calculate its volume, right? It's just 4 pi r cubed divided by 3. Which allows you to calculate, because we know it's 1 kilogram, and we know if this is the size of it, we can calculate its actually, because we know that, we can calculate its density, and so we can calculate how many atoms are in inside of the 1 kilogram sphere. This allows you to fix Avogadro's constant. Avogadro's constant is based on the kilogram. It's based on the kilogram. So Avogadro's constant is based on the kilogram. Kilogram, you know, Avogadro's constant. It depends, so it's 12 grams of carbon-12. It depends on what 12 grams is, but it depends on what a kilogram is. But then the silicon sphere would allow you to fix Avogadro's constant, which allows you to define the kilogram. As little as they possibly could. Except that didn't happen. So we're hoping that it will happen today with a different approach. This is where we get to bring in some physics as well. This is how it's going to be done. We'll fix Planck's constant. You might say, what's the difference between Planck's constant and the kilogram? Well, the Planck's constant relates the frequency of a photon to the energy. okay? But we know that E is also equal to M. But we also know that E equals mc squared. And so we can now eliminate E. Then we get this. Then we divide both sides by c squared. Now if m is 1 kilogram, then we've got a relation between Planck's constant and the frequency of a photon and the speed of light in a kilogram. Now, we know Planck's constants really accurately, but the last digits are actually uncertain. We don't know if the last digits are right. But we'll fix those last digits. We'll know the last digits for sure, which allows you to use this formula to calculate a kilogram. The mole will do the same thing with Avogadro's constant, which is based on a kilogram. For the Kelvin, we'll do the same thing with Boltzmann's constant, which is also based on a kilogram. And the charge of an electron is for the ampere, which is actually also based on a kilogram. So we're gonna redefine the ampere, the Kelvin, the kilogram, and the mole. The solar ampere is no longer a kilogram. So why are we doing this? It's to fix a kilogram so that's not changing anymore. Right? Because remember early on in this video when I talked about the history of a kilogram? The masses were divergent. But in theory, Planck's constant is, well, a constant. And Avogadro's constant too. And Boltzmann's constant too. And the charge of an electron too. Which means that we can fix the constant so that they are a constant. And then based on that, we can figure out the mass of 1 kilogram. I hope this was a good video. If not, that's fine for me because I don't really I don't really know how to make good videos. I don't really talk so well. And I don't really make any good videos of quality of stuff where I could speak properly. So, that's absolutely fine if you don't like this video, but the point is to kind of, because the whole point of this is to show that au revoir, the current definition of the kilogram, maybe, if the vote isn't going to go well.